All right, we're back with question number 4 on your homework. So this is question number 4, and we're going to see if we can change this color right there. So now what they've given us, notice that our givens right here, they've told us that that line JK is parallel. Notice that those railroad tracks, that means parallel. So these two lines, JK and LM, are parallel. Now they're not congruent. That's important to note. That doesn't mean that they're congruent. That just means that they're parallel. Whoops, where did my screen go? Sorry, not sure why that keeps doing that. And then over here, JL right here is parallel to KM. So these two lines again are parallel, not congruent. Don't mix them up with congruence. All right, so the reason that they actually tell us that lines are parallel is to tell us about the angles. So if you remember from last unit, from our parallel lines unit, we talked about how parallel lines, if you know parallel lines, then you know that alternate interior angles are congruent. You also know alternate exterior angles are congruent and corresponding angles are congruent. So we're not even going to worry about the consecutive interior angles. They're supplementary. And when we're trying to prove triangles congruent, we don't really care about if they're supplementary. We just want them congruent. So these are going to be our only 3 theorems that we're going to use when we know lines are parallel. So again, these were our givens right here. And then the very next thing that they tell us about, notice right here, they tell us that these two angles are congruent. So angle JKL, this angle right there, is congruent to MLK. MLK right there, that angle. Now, notice really quickly, let's look at this. If we took these two lines, these are the first 2 lines that they told us were parallel. I'm going to kind of draw that line. And then this line, I'm not doing very good dash lines. So anyway, those 2 lines, if we take those as our parallel lines, which they are parallel, and we look at this as our transversal right here, notice what kind of angles are these 2 angles? Yes, that is correct. They are our alternate interior angles. So we're going to write the alternate interior angle theorem states that those 2 angles are congruent. Now, if you look at the other 2 lines, let's do this one in blue. So now if we look at these 2 lines as our parallel line, same transversal right there, but now they're going to tell me that these 2 angles are congruent. They're going to say that angle JKL, oops, I've messed up, but that's J, here's K, here's L. No. Darn it, I don't even know how to move this stuff around on this whiteboard. Let's see if we can look where there's JKL. I think that I did the wrong one up here, but this one is alternate interior angles as well. These are also alternate interior angles right there. So one of them belongs to the first lines that were parallel. The other one belongs to the second lines. I probably put them in the wrong order, but just note that they are both alternate interior angles. They are both congruent. Okay, and then the last thing that they tell us, or that they have in their proof, is that they say that KL right here, here's K and here's L, so this line is congruent to itself, that same line. Sorry. So I'm just going to make maybe 3 ticks. That's congruent to itself. Now, this is my favorite property right here. This is, and you laughed when we first introduced it, but this is the reflexive property. We said any number is equal to itself. Any number is congruent to itself. Any line segment is congruent to itself. So that is your reflexive property right there. Now, notice what you have. Let's try green right here. We have this red angle, a side, and another angle right there. So when we're looking at our congruence theorems, remember there was side, 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 angle, side, angle, angle, side, angle, side, angle, and hypotenuse leg. So when we're looking there, we see that we've got 2 angles, and that side right there is in between our 2 angles. So this is going to be our angle, side, angle congruence theorem right there. And we've just proven that those 2 triangles are congruent to each other.